So this is a monopropellant engine. Monopropellant. Yep, it is in Kerbal. Go for it. So a monopropellant is something that you only need one thing to make it go. You don't need an oxidizer. You don't need a fuel. You can use just a single fuel source. That's why it's called a mono, meaning one propellant. So we have pressurized helium in this, a monopropellant, which is oftentimes hydrogen peroxide. The peroxide goes through this filter and then through the valve. There's a catalytic chamber. You're running some electricity here. The electricity catalyzes the decomposition of the peroxide into hydrogen and oxygen, and then they reignite right here, and then you get exhaust gases. Okay, so this is another type of a liquid fueled engine. Essentially, really what it is you're just making a much simpler liquid rocket engine. Yeah, so monopropellant thrusters you can use to orient spacecraft in orbit. They're very useful. They're very reliable. They're generally very small. You can't really make a large monopropellant. Okay.
So what's the energy of hydrogen peroxide breaking and reforming to H2?
So what's the energy?
Yeah, like the total overall enthalpy.
The enthalpy?
Yeah.
I know that hydrogen is something like, I think it's 140 kilojoules per mole, something like that.
The bonds forming the exothermic, but it requires energy to break the bonds of hydrogen peroxide.
Correct.
So is the overall process exothermic or endothermic?
Well, the overall process consumes energy.
Okay.
But most of that energy goes into entropy, just heat, waste heat. So yeah, these are pretty simple. Now, if you think that is simple, monopropellants, now let's look at what is called a cold gas thruster. Cold gas thrusters are as simple as they get. And you're thinking, am I looking at that correctly? You sure are. Pressurized gas with a valve to a thrust chamber. That's it. So when in space and you want to orient a spacecraft, you can use pressurized gas. Usually they use nitrogen, because nitrogen is everywhere. You just pressurize the crap out of this nitrogen and put it in a pressure vessel right here. And then you just have a little valve that goes psh, psh, and it just lets the gas out. And when you it's essentially a fire extinguisher.
It sounds like the equivalent of letting go.
Yeah, that's exactly what it is.
This is like the most simple thruster possible.
Yeah, this is, I have a balloon, I'm in space, I open the neck of the balloon and I generate thrust. Yes, Aiden?
You can hold a Wally.
You can pull a Wally, yes. Fly around with your fire extinguisher. Yeah.
This will like malfunction to make Belmont stages spin around a lot.
Yes, this is what malfunctioned on Gemini 6.
It's the most simple thing.
Gemini 8.
I was like, that's not sick.
Yeah, it's Gemini 8. Yeah. This is what malfunctioned on Gemini 8. One of these thrusters got stuck open.
I'm embarrassed. Your most simple engine.
Yeah.
Really just a valve.
Yeah. Oh no, the valve got stuck. Yeah. No, I think that what they weren't anticipating is that the valve froze. And it froze in an open position. So yeah, those are cold gas thrusters. I mean, here's a slightly more complex one.
Oh, yeah, it's so complex. Man.
I know, right? So really what this is you have a propellant tank, which is just a high pressure gas, and a series of regulators and valves. These regulators just make sure that you're getting equal thrust to all of the different nozzles. So you can have a single tank that feeds multiple nozzles. Then you just go psh, 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 and you go around. So you may recall when did you guys watch me dock part of a space station in Kerbal?
Yeah.
We use what's called reaction control thrusters, which are just cold gas thrusters. Okay, this is called a cold gas or pressurized gas thruster. They're very, very simple. They're generally very reliable. Generally very reliable. If you want an even simpler, this one is fantastic. I just want to show you. I just want to show you how simple this is. Somebody felt it was necessary to make this image. This is like, look at this. Boop, 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 boop. Okay. So there's that. So there's cold gas thrusters. There are monopropellant thrusters. All right. They're generally very simple. Now let's talk about electric propulsion. Yep.
What about gas thrusters? Like neon gas?
That's what we're getting to. This is a very futuristic looking engine. And yes, that's actually what it looks like. Can I get any of these pictures to not be tiny? Okay, yes, it looks super futuristic. Yeah. Yeah, so ion thrusters are very, very interesting.
We're basically using modern stoves as the propulsion. That's what this looks like.
A modern stove. Yeah. So these things are super fascinating. Let me pull up a schematic for one.
Aren't they like really weak?
They are extremely weak. For some reason, when I do this in Google, what the world? For some reason, it doesn't want to pull it up in full resolution. Okay.
Shotgun.
Yeah, it's essentially it. Electron gun. So here's the way that these things work. All right, you have these magnets around the outside that create a charged environment. You shoot electrons through here. The electrons hit into these atoms. Okay? And what happens is you end up knocking an electron off of the atom, making these ions. Okay? These are positively charged atoms. Generally, we use xenon, which is a non-reactive noble gas. And what's nice about xenon is it is heavy. And if you can accelerate it really fast, then it creates more thrust. Okay? So you knock off the electron, making it positively charged. You use these electromagnets around the outside to essentially accelerate these ions to near the speed of light.
Wait, so this actually creates pretty awesome amount of stress. I thought this was pretty.
This creates an extremely efficient amount of thrust. Extremely efficient amount of thrust. And then you shoot. Yes, I believe that MIT or Caltech or some university made an ion thruster plane. They are very weak. It had to have like 12 wings. What? It doesn't give you a lot of thrust, but it's extremely efficient.
I made a rocket ship up to the and then I added like so much, like insane amount of it was so hard to make. It was so heavy. But now it will like literally go anywhere forever. It has so much fluid.
Yeah. So the efficiency of ion thrusters is what makes them so useful. Okay. Once you're in space, the problem with Earth is that Earth has a very strong gravitational field, boo, and a very thick atmosphere. Thank you, Michael. Boo to both of those things, even though they keep us alive. The gravitational pull of Earth is difficult to overcome, and the atmosphere provides a lot of resistance. Once you are in space, at least in an orbit around the Earth, ion thrusters are ideal because you are able to generate a huge amount of delta V, change in velocity, over time. It just takes a long time. Okay? Instead of burning a chemical rocket for a few seconds to generate thrust, you burn one of these, you fire one of these for several days to generate the same amount of thrust. They are, however, super duper crazy useful. All right? The Dawn spacecraft. The Dawn spacecraft was one of the first spacecraft to use an ion thruster in space. And what was so cool about this ion thruster on the Dawn spacecraft is it allowed it to visit not one primary target, but two primary targets. So we had enough thrust, enough change in velocity, or delta V, to be able to go to Ceres and Vesta, the two largest asteroids in the asteroid belt. If we were to use chemical rockets, there's no way that we would have been able to do that. Okay? Because we use these ion thrusters. All right? I mean, sure. If you had strong enough electromagnets and some way to make an electron gun.
How hard is it to make an electron gun?
It's not impossible.
Can we make it with the tools you have here?
Would it just
Here, not in this classroom, no.
Would it just fall really slow if we made one here?
Would it fall really slow?
Yeah, if we made, no, if we
I
made
think
a tiny little electron mag, if we made a tiny little ion thrust.
No. So the Earth has a gravitational acceleration of 9.8 meters per second squared, right? These things, if you put it on an extremely light spacecraft with a very powerful ion thruster, you might be able to generate an acceleration of something like 0.005 meters per second squared.
So we will just float it.
No, it would look like it was just falling at a normal speed. Because you have reduced the gravitational acceleration from 9.8 meters per second squared to 9.7995.
So if you're falling next to it, it would fall just very slower.
Just barely. Like you point that ion thruster straight down and you fire it at maximum thrust, and it would still just fall essentially at the same speed.
What? Wait, hold on. How did we even? Okay, so we created it, saw that it basically did nothing. Only saw that it lasted a while, so we put it in space and then nothing.
No, so the way that we can test these things on stands. You put it on a stand. You put it on its side. You have some essentially like clamps that measure force. Clamp it down, turn it on, and then you can see that it's generating thrust.
Very, very minimal thrust.
Very, very low amount of thrust,
But
it's still generating thrust.
with the tools we have in the school, not just in this classroom, in the school, can we make at least an electron gun?
Probably not. I don't know everything that's in the school, but I don't think that we'd be able to make one of these.
If we put it on the floor, if we made one, put it on the floor and waited like 3 days, we'd be like, oh my God.
You might be, if you made it, yeah, if you put it like on a ball bearings and like something super, super light, it might be able to move it a little bit across the floor.
Wow.
Okay, these are very, very weak, but they are super, they look really cool. They look super futuristic.
I just saw one in my room.
This is a real image, by the way. This isn't some artist rendering. This is a real image, yeah. This is what they actually look like.
Like that's not like what the
That's what the thruster looks like, yeah.
no, I mean like the thing coming out.
Yeah, this is the ion stream coming out of there. This is actual xenon. These are xenon atoms that have been ionized and then they have been accelerated like hell. They've been accelerated like an extreme amount by these magnets. Not a lot.
Would it just kind of feel like if you went?
It might. Well, it would push the air. It would push the air, and so you'd feel like a little breeze.
Would it feel like your hands were and like it felt like little grips on them? Or no?
No, I don't think it would be that dangerous. I might be completely wrong about that, so don't quote me, but I don't think it would be that dangerous. Yeah, Phil.
Two things. You could flex that you have the most expensive but like weakest desk fan you could possibly have. And then two, how good would these work as a generator,
Electric generators?
Yeah, if you like somehow, I don't know.
Well, the whole thing about these things is that they, yeah, like Sam said, they take a gigantic amount of electricity.
Never mind. These are generator destroyers.
Yeah, these are electricity users. You may have seen something like this before. You may have seen something like this before. This is an Ionic Air Filter.
Oh no.
These actually work. And they use kind of a similar process.
I was only joking about the desk fan.
No, this is literally like a desk fan that uses an ion thruster, but it's a little bit different. It's not using super strong electromagnets, and it's not using an electron gun to ionize xenon. What it does is it's grabbing free ions or particles in the air and then pulling them in and then shooting them out using magnets.
That's cool.
So it's
it doesn't require
so this actually generates thrust. Do you realize that? Because it's shooting air out one side faster than it's bringing it in, it's generating thrust. Yeah, you have to plug it into the wall.
Okay, you got
Would
it.
this fall slower?
No.
Well, because you need power.
Yeah. Okay. So any questions about ion thrusters? No. Okay. They're very cool, very useful.
Okay, look at the plane. Wait, so we do have a question.
Yes. Okay. Let's look at the plane.
So how does it clean the air?
It's some of the dust particles are charged, and so they stick to the magnets.
Oh. They're right.
Let me see here. Where? Oh, here it is. Huh?
Oh, so it's like you can't even go in it.
Oh no. This is a little tiny model airplane.
Man. Dude, it's dumb.
But it's using ionic thrust.
I guess they expected myself.
So this doesn't have any moving parts. That's what's cool about ion thrusters. They have no moving parts. Okay.
Sounds fake.
So,
Wait, hold on. Can you keep itself like flying infinitely and have like enough solar panels, like a solar panel to ion thrust ratio?
yes.
It can
Yeah.
keep itself flying forever.
Flying in atmosphere.
Yeah.
Yeah. Because it uses the air. It passes the air through the charged ion plates.
Before it powers something, you can rely on solar.
It could rely on solar. Yeah.
It's crazy.
Okay. It could do that. Obviously, you'd need to have batteries. You obviously need to have batteries to like go through the night. But
Just
yeah.
grab some of those air cleaners you were talking about, like a chicken salt. Just fly thousands of
Okay. Shush. Elijah, what was your question?
Oh, you answered it.
Okay.
Just really.
They're so amazing yet so disappointing.
So yeah, these are really cool. In space, these cannot go indefinitely because you have to have xenon in most cases. You may have heard of. Has anyone heard of SpaceX Starlink?
Yeah, sort of.
It's a fun game on Android.
So Starlink is a product from SpaceX.
Or chips inside your head.
No, this is internet from space.
Wait, hold on. What was like you're doing all black guy?
So instead of using like a fiber or cable that you have to plug into a modem, these use these dishes to communicate with a constellation of hundreds of satellites, soon to be tens of thousands of satellites in low Earth orbit. Starlink is pretty cool. You can use it literally anywhere. So if you have power and
That's sick. Why is this being promoted?
if you have power and you can see the sky, you have internet.
Wait, so in my house I would have bad internet.
You need to put it outside. Yeah.
So
I
just like a satellite.
Yeah, it is a satellite. Yeah, it's a satellite dish that just kind of goes, and then it uses some really cool electronic phased array things to communicate. Anyway, really cool. Internet everywhere. We're talking the middle of the Sahara. On top of the mountain, any mountain, in the depths of the Amazon.
I'm pretty sure the only reason that this thing has not skyrocketed in the stock market is because it's very close to Skynet.
So the reason why this is not taken over the internet world yet is because it is not yet fully functional.
What is that? What expand?
They're still launching the satellites that they need for it. I believe right now there's like 600 something satellites in orbit that eventually they plan on having 12,000.
How much? Yeah. I would buy this.
Right now, I was looking at it myself. Right now, I think that for me, it would be like $200 a month, but that price is going to be coming down. It's actually really not that bad for high-speed internet.
Yeah, that's not bad.
For a high school student, that is.
Yeah, but like, doesn't normal internet cost?
So my Comcast Xfinity internet, I think, is $85 a month.
You said it's $200.
Yeah. So more than double.
But you can go travel.
But what's cool is I can put it on the back of my, or on top of my car. We can go to the middle of the New Mexico desert, and I can just plop it on top of the car. Okay, so shush. Anyway, the reason why I bring this up is, can I look at the satellites? The satellites use ion thrusters.
Wait, when I grow up and it gets cheaper, I'm done for my internet.
I doubt it'll be cheaper. They really believe in like internet for all.
It will be cheaper. It will be cheaper. Their main demographic, their main target demographic is like Central African and East Asian underserved peoples.
I thought this was so like they can support more projects. You know, that's why they would make this.
Yeah.
The money they're already
So their satellites look like this.
Wait, how does SpaceX get its money?
Through launch contracts.
So what's
Starlink
up?
is a central internet. What?
Skynet in disguise.
So there are these interesting like pucks. They're very flat. Here's the ion thruster right there. And they have these gigantic solar panels.
They look like ships, sail ships.
Yeah.
Wait, this.
And they stack 60 of them inside the Falcon 9 fairing.
Wait, so they send like 60 every single launch?
Yep, every launch they send 60 of these things.
They must be lightweight.
Yeah, they are. Anyway, pretty cool. They use lasers to communicate with each other. Yeah, it's pretty cool.
Starlink is really utopian. Like,
How
These
big
are
are
kind of aerospace engineering projects.
Yeah. This is what they look like right after launch. Like right after launch, if you see them right after sunset, this is what they all look like in a row. A lot of people are like, oh my gosh, look at those UFOs. And it's like, they're satellites, guys. Anyway, pretty cool. So ion thrusters.
I love this.
All right, last thing that I want to talk about in the realm of very exotic propulsion systems, let's talk about warp drive. And how it is possible. So right now, as far as we understand, we are only able to travel through space at a maximum of light speed.
well, we're trying to raise that, or what? Are you raising that?
But, so this is obviously not technology that exists yet, but in the future, humanity may break the universal speed limit of 300,000 kilometers per second, which is the speed of light, using something like this. This is an Alcubierre warp drive. A Mexican mathematician and physicist named Alcubierre, I believe his first name is Miguel. He came up with the physics that would be needed in order to travel through space faster than light. The way that we fix that, so nothing can travel through space faster than light. The way that we cheat this problem is that space itself can expand and contract faster than light. You ride a wave of expanding behind you and contracting in front of you.
But that would theoretically that means you be left in darkness, right? Because you're ahead of light.
Well, the bubble around you would not look any different.
Yeah, you'd still collide.
So here's what you would do. So there are two ways. There are two ways for me to get to the end of a rug. Okay, I want you to imagine a long rug. Okay, let's say it's 10 meters long. Okay, it's a really long rug. There are two ways for you to get to the end of that rug. You can walk from one side to the other. Or you can cartwheel, sure. You can physically move yourself. You can physically move yourself from one end of the rug to the other. I want you to imagine that this piece of paper is my rug, okay? We're standing here, we want to be over here. We can walk to the end, or we can bring the end of the rug to us and then step across. It is not cheating. At least not as far as the universe appears to behave. We can simply fold the rug in front of us, step across, and now we are at the other end of the rug.
So how do you do this?
How do you do this? Some very exotic energy.
And how do you execute that?
So this here, in order to shrink the universe in front of you, you would need the negative equivalent of dark energy, which we don't even know what dark energy is, and we don't know if there is anything that is equivalent to negative dark energy.
We need positive energy or light?
You would need positive dark energy behind you to expand the space behind you while you contract the space.
So negative in front of you, positive behind you.
Yeah.
We were trying to find this, or we were trying to produce and create.
We'd need to make this. So, but this is, according to the mathematics, this is not impossible. So space itself can expand and contract faster than the speed of light. We know this because we see the universe expanding faster than the speed of light. The question is, can we make it do it on command?
We're coming a long way since the search fire.
Yeah, yes, we are. This is not a technology that will exist anytime soon. My guess is that warp drive, if we ever achieve it, will be something like 10,000 years in the future. But if we are able to make this, this would completely alter what we understand about the universe. You would be able to travel from here to Alpha Centauri, the closest star. You would be able to travel there not in 100,000 years, which is the current rate at which we could travel those kinds of distances, 4 light years. and not in 4 years, because that's how fast light goes. You could go there in a matter of minutes between star systems. Yeah, so this is essentially Star Wars and Star Trek kind of technology. Okay?
But it's mathematically true.
It is mathematically possible. That does not mean that physics would agree, but math says it's possible. Okay? So those are our different types of propulsion that I wanted to talk about today. This is called the Alcubierre warp drive. A-L-C-U-B-I-E-R warp drive. Okay. So, pretty fascinating. Pretty fascinating stuff. Okay? Hopefully you learned something today. We'll finish the video here.